In this podcast, we're going to be learning how to change radicals to exponents, exponents to radicals. We're going to learn how to evaluate numerical expressions with rational exponents, and then later on, we're going to be solving equations with rational exponents. Right? So after we've learned how to evaluate, then later, our last lesson will be solving equations with rational exponents. So let's learn what a rational exponent is first. All right, so we sometimes call it the nth root. So we can have radical form, and we can change that to rational form. Okay. Thought I had my little handy dandy arrow. Here it is. All right, so of course that's our index number. Of course we know if it's a square root, we don't generally write that in. This is our radicand. It's under the radical. And unless there's an exponent, it's understood it's raised to a power. All right, so now if we want, and it's raised to a power of 1, excuse me. If we want to take that radical and change that to rational form, so it has an exponent, what's under the radical is going to be our base. And then to get the exponent, the numerator is just going to be the exponent on the radical, and it can be 1. And the denominator is going to be the index to the radical. Right? And so it's going to be 2 or greater. Right? So the index number becomes the denominator of the exponent, and if there's an exponent, that becomes the numerator. Right? So if we have the nth root of a, that could be rewritten in rational form as a to the 1 over n. Right? So converting roots into fractional exponents. Any radical expression may be transformed into an expression with a fractional exponent. The key is to remember that the fractional exponent must be in the form power over root. Right? So if there's an exponent on the radicand, right, the exponent on the base, that's going to be the power that goes in the numerator, and then the index to the radical, that goes in the denominator. Right? So here we have the square root of 16. Normally we don't write an exponent of 1 or an index of 2, but those would form the exponent on our radicand. Right? So the radicand 16 becomes the base, and then whatever exponent was on 16, in this case 1, is the numerator to the exponent, and then the index to the radical, that's the denominator. So square root of 16 is the same as 16 to the 1/2 power. Here we have negative 2 to the 5th power, the cube root of negative 2 to the 5th power. That could be rewritten as negative 2 to the 5/3 power. And it actually, in this case, it won't matter if the parentheses are on or not, because your exponent is odd and your index is odd. That's going to be a negative number no matter what. All right, so now we've learned how to convert roots into fractional exponents. And we can go the other way. Right? Here's some more examples. All right, so actually we're going to focus still on radical form and exponential. Sorry, we are going to go the other way, but not yet. All right, so change to exponential form. All right, so then the exponent becomes the numerator of the exponent, and the index to the radical, that becomes the denominator. So the cube root of x squared is the same as x to the 2/3 power. If you like, you can use parentheses on this one, but it'll be the same either way because x is positive. Right? And so while this works out, it's the same as the cube root of x squared, and we could rewrite the cube root of x squared as x to the 1/3. And so when we raise power to a power, we multiply those exponents. So 1/3 times 2 is 2/3. Right? So x to the 2/3 is the same as the cube root of x squared. You can also think of it as taking x squared and taking the cube root. Right? So the exponent for cube root is 1/3, and then if you were to multiply the exponents here, right, 2 times 1/3, that gives you 2/3 either way. Right? So the cube root of x squared is the same as x to the 2/3 power. When rewriting in exponential form, include parentheses if the base is negative and the exponent is even. then parentheses are needed. Otherwise, you'll have the wrong sign. All right, so if we have the cube root of negative 64 squared, right, when we take the cube root, make sure you use parentheses, because when we square that negative, it's going to become positive. Without the parentheses, the cube root of negative 64 squared, right, that would give us negative 4 squared, but it's not in parentheses. The negative is not being raised to a power. Exponents only apply to what's directly in front of them. Right, so negative 4 squared without the parentheses gives us negative 16, which is not the same as 16. So I believe this is in your notes. In exponential form, if we have the cube root of negative 64 squared, right, that's going to need parentheses, right, because we're going to have a negative number, and when we square it, it's going to be positive. All right, so that's the same as negative 64 to the 2/3 power. The cube root of 64 is negative 4, so we have negative 4 squared, which is 16. All right, so remember, if you have a negative base and your exponent's even, right, the numerator's even, then make sure you use parentheses so you raise that negative sign to a power as well. If the base is positive or the exponent is odd, parentheses are optional. Right, so here it's positive with or without the parentheses. Oops, it's going to be the same thing. Right, so we have the cube root of 64 squared. Cube root of 64 is just 4. 4 squared is 16. Right, so parentheses don't matter. Right, so here's that one was with the parentheses. If we have without the parentheses, notice 4 squared is still 16. Right, no negative. Right, we don't need the parentheses. But if it were negative 64 to the 2/3 power, that would need the parentheses, because we'd have to raise the negative to a power, otherwise it wouldn't be equal. Also, doesn't matter if you have the parentheses, if it's a odd root. Right, so here we have the cube root of negative 27 to the 5th power. With parentheses, cube root of negative 27 is negative 3. Negative 3 to the 5th power is negative 243. If we don't use parentheses, cube root of negative 27 to the 5th power, cube root of negative 27 is negative 3. Negative 3 to the 5th power is still negative 243. Right, so in exponential form, the cube root of 64 squared, right, is the same as 64 to the 2/3 power, with or without parentheses. Cube root of negative 27 to the 5th power is going to be negative 27 to the 5/3 power, with or without parentheses. It doesn't make any difference. Whoops, there's my arrow. When writing into exponential form, make sure you reduce the exponent if possible. All right, so my base, under my radical sign is 15. That would be the base, and then it's exponent over root. All right, so that would give us 15 to the 3/6 power, but we could reduce that. Right, that would reduce to 1/2 because they're both divisible by 3. All right, so the cube root, the 6th root of 15 cubed, and 15 to the 3/6 power, and 15 to the 1/2 power are exactly the same. All right, so these ones we're going to do together. They're not whiteboard practice. All right, so we're going to rewrite this in exponential form. All right, so exponents understood to be 1, index understood to be 2. This would be 14 to the 1/2 power. Over here, exponents understood to be 1. This would be 11 to the 1/3 power. On the next one, we have 5 to the 2/3 power, right, because the exponent is the numerator and the root is the denominator. And then this is understood to be a square root. This would be 16 to the 5/2 power, right? And that's all there is to changing from radical form to rational form. Okay. Now let's go the other way. So we're going to change exponential to radical form. All right, so here we're going to change this in exponential to radical form. Whatever the numerator is, that's an exponent on your base. Whatever the denominator is, that's an index to a radical. So x to the 2/3 power becomes the cube root of x squared. And the parentheses are optional here. because it's positive. So as a reminder, x to the 1/3 is the same as the cube root of x. So the denominator of the exponent becomes the index number to the radical. So rational exponents, little summary here. All right, so the exponent 1 over n indicates the nth root. In numbers, 16 to the 1/4 power is the same as the 4th root of 16. In this case, that's reducible. That would just be 2. In algebraic terms, a to the 1/n is equal to the nth root of a. The exponents m divided by n indicate the nth root raised to the mth power. So here we have 8 to the 2/3 power, which can be rewritten as the cube root of 8 squared. You could take the cube root of 8, which is 2, and 2 squared is 4. And then again, a to the mn power, that could be rewritten with or without parentheses, because a is positive, as a to the nth root of a to the raised to the 5th power. And there you go. So denominator of a rational exponent becomes the index of the radical. Right, so when writing into radical form, include parentheses if the base is negative and the exponent is even. Parentheses are needed. Right, so here, negative, positive, make sure you use parentheses. If the base is positive or if the exponent is odd, parentheses are optional because it won't make a difference. So 64 to the 2/3 power, it's positive. We don't have to worry about parentheses or not. That would be the cube root the cube root of 64 squared with or without parentheses. Here we have negative 27 to the 3/5 power. That's the same as the 5th root of negative 27 cubed with or without the parentheses, right? Because it's an odd index. It's going to be negative no matter what. It's a positive number. It's going to be positive no matter what. Right? We need the parentheses when we got a negative and it's being raised to an even power, because we got to make sure that, an even exponent, so that we make sure that we raise the negative to that power as well. All right, so let's write this one into, and these are all in your notes, by the way, this set and the other set. Let's rewrite this one into radical form. So this would be, right, so the 1 there is an exponent, and the 3 is the index on our radical. Index. So this would be the cube root of 6, and I don't need to put an exponent of 1. Right, this would be an exponent. This would be the index. So this would be the square root of 7. And I don't need to put the exponent of 1, and I don't need to put in the index for square. This would be the exponent. This would be the index. This would be the square root of 10 cubed. Likewise, I don't need to write in the index because it's a square root. And then the last one here, this would be the exponent. The 7 is the exponent, and the 3 is the index on the radical. So this would be the cube root of 8 to the 7th power. Right, if we were asked to, we could evaluate that. In this lesson, we won't necessarily be evaluating. Just rewriting for right now. All right, so now we're going to rewrite and simplify. All right, so when you simplify radicals, take the root first and then raise to the power whenever possible. It makes it easier. So here we have and it's easier actually to evaluate when it's in radical form. So here we have 256 to the 3/4 power. That 4 is the index on the radical. 256 is under the radicand, or is the radicand of the radical. And then we're going to cube that. All right, so we're going to take the, so 256 That, by the way, is 16 times 16. And then, which is 4 times 4. So 1 4 comes out, 3 4s go away. So 4 is definitely our answer here, but we're not done, right? Because we need to cube it. And so 4 cubed is 64, and that's our final answer. Let's look at the other problem here. We have negative 27 to the 5/3 power. All right, that's the same as the cube root of negative 27 to the 5th power. Parentheses are optional, right? Because it's an odd index, but it does look nicer. So we're going to take the radical first. Cube root of negative 27 is negative 3. And then we're going to raise negative 3 to the 5th power. That's going to be negative 243. And there we go. Right. And that's the end of this lesson. All right, so here's the whiteboard practice. Now you see 4 sets. You're going to only do 1 set. And here's an easy way we'll figure this out. All right, so, and we'll do it by letters of the alphabet. So let's see, there's 26 letters in the alphabet. All right, so if we're going to divide it by 4, that's going to be 6. All right, so if you are A, so A, B, C, D, E, F. A through F, this is your last name. All right, you can do set 1. If it's G through, so G, H, I, J, K, L, you do set 2. If you're M through M, N, O, P, Q, R, and then everybody else, S through Z, you can do the last set. All right? Easy way to divvy that up there. All right, thanks for watching, and bye for now.